Okay, so yesterday we worked on the basics of antiderivative. We introduced what is indefinite integral. I want you to just recall that we have this notation f of x dx, long as f of x dx, we call this indefinite integral of f. And it's just a cryptic way of saying all the most general form of antiderivative of f. So we want to show, instead of each time saying antiderivative, we want to use this funny notation. And we did some examples yesterday. I want to start doing more examples. Remember that we had this table of integration, so we have different entries. And we had two properties about this indefinite integrals. It is additive. It works nicely with scalar multiplication. Or in other words, it's linear with respect to addition and that. So now I want to do these examples. Evaluate the integrals. One is 30 over 1 minus x squared plus x dx. Integral of 5 secant squared x plus 3 to the power x dx. Another one, integral of, I think I can write it here, 2 sine x plus sine of 2x dx. Okay. You have the table, you have the properties. Now I will give you 2 minutes, and you're trying to break down these integrals to smaller. Wait, I had one more. I remember where I didn't write that one. I'll write this one as well. Just. Yes, now I have 4 examples. 2 minutes, and while you're doing those in 2 minutes, these questions, I will get our iClicker question for today ready, and then we will start that. 2 minutes starts now. Go ahead, please. Use the table, talk to the friend, and get this thing done. Thanks. 1 minute left. we want to use the properties, break this integral into small integrals that we can use the table entries that we learned yesterday. First, I can do this plus that, but then that third is a constant. I can take that one out. I have one integral like that, and the other one is x dx. Now, integral of 1 over root 1 minus x squared, that is, that's an entry in our integration table, and that is antiderivative of sine inverse x plus integral of x to the power n. The rule was this: if you have x to the power n dx, there are two cases. If it is n is not negative 1, then you do add 1 to the power, divide the whole thing by n plus 1. If it is negative 1, then it is ln of absolute value of x. Both of them, the way I wrote is wrong. You have to add that plus c there so that you get everything in place. So in this case, n is 1, so I add 1 to that, that's 2. I divide the whole thing by 2. Now, you get plus the whole one thing c. This other one, we have 5 integral of secant squared x plus dx, open bracket, close bracket, plus 3 to the power x dx. Now, antiderivative of secant squared is tan x, yes? So there's 5 there, 5 tan x plus b to the power x. Antiderivative is b to the power x, but you have to divide it by ln of b so that we can cancel that ln b that is generated there. And then we put plus c for the whole antiderivative. Here I have 2 integral of sine x dx plus integral of sine 2x dx. Antiderivative of sine x is negative cosine x. Antiderivative of sine 2x. Okay, so I can say that, okay, if it is sine, it is coming from cosine. So the derivative of cosine is negative sine, so there's another negative sign there. But if I differentiate this one, I'll get a factor of 2 up front. This doesn't have that factor, so I will divide this by that factor so that when I differentiate, they cancel, that 2 cancels with the 2 in the numerator. And plus c, that's the general. By the way, what I'm doing here is part of a bigger story called, or larger story called substitution. We will work on that a little bit more later on. But for simple examples, you should be able to see it right there. Like, okay, and when I differentiate minus cosine 2x, I get that 2, so I have to divide it by 2 so that they cancel out. When it comes to this example, unlike differentiation, which we have a rule for quotient and product, in the indefinite integral or anti-deriving, we don't have any rules for fraction, quotient, or product. And that's why integration is way harder than differentiation when it comes to the rules. So you have to learn so many techniques to be able to complete those ones. In other words, when you come across such a thing, don't even think of you have a rule to solve that. But in this specific case, we can break this expression and write the denominator for each term. So the first term would be x to the power 5 over x, that's x to the power 4, minus 3x to the power 4 over x, that's x to the power 3, plus x plus 1 minus 1 over x dx. Now I have different terms of this thing, which I can go ahead separate into terms, and in all of these guys, the power rule will be doing the job for us. And then you have power rule, x to the power 5 over 5 minus 3x to the power 4 over 4 plus x squared over 2. I'm adding 1 to the power. I'm dividing the same thing, the expression by the same number, plus integral of 1. You can see it as x to the power 0. Then you add 1. That's x to the power 1 divided by 1, which is x. Or simply, what is the function whose derivative is 1? X. Thank you. And integral of 1 over x is not, antiderivative of 1 over x is not ln x. If we want to get the whole domain for that, it's ln of absolute value of x, and then you go plus c. So you need, or we need to do more differentiation as much as, or more integration as much as we can. At least in this level, we have a small group of examples that we can do, and we need the practice. Any questions, any comments? Are we all good with these things? Definitely more examples will be helpful. Then I will turn on the first iClicker question. Here. Can anyone please confirm that you see? Do you see it? Yes? Could you please check that? Yeah? Okay, thank you. Your iClicker question is on. I'm expecting to see the answers as soon as in a minute. Okay, 30 seconds.
I'm gonna go over every single number. I wish.
Read no submission. So our setting this.
Okay, so antiderivatives is another way of saying evaluate this indefinite integral. So we have integral 3 comes out. We have this integral there, and then I can break this integral into 2 integrals. Here, root x over root x to the power 3, that will give me 1 over x. 1 over the root of x cubed, I can write it as that. Now, I will separate each one. That negative sign needs to be multiplied there. Okay, 3 integrals. Integral of 1 over 1 plus x squared. That is antiderivative. The antiderivative of that is tan inverse of x. Or the derivative of tan inverse is 1 over 1 plus x squared minus ln of absolute value of x minus. So this is x to the power negative 3 over 2 plus 1, which is negative 1 over 2. And then 1 over that term plus c. Everything is there, but this one, if you simplify that, with this negative multiply, you get plus 2. X to the power negative half is root x in the denominator. And that makes our answer the last one in the list. I'm going to close the iClicker. Please put your stuff in. Put your answer quick.
We get 1 over.
5 more seconds. Okay. Now, one thing, I am now going to open another iClicker question. Listen carefully. Do not answer to this question that I'm sending. Do not answer to this question that I'm posting now, okay? You will see it all, but do not reply back to that question. Well, we have noticed that there are people who are not in the class, but they are responding to iClickers. So we are trying to get who else? I already have 8 people, 8 responses in. 10. I think some people are in trouble. Maybe let's wait a few more seconds. Okay. Okay, let's see. The last piece of this section is about something that when you put in wording, it's obvious that when you're looking for antiderivative of f prime. So if someone gives you derivative of function and says what is the antiderivative of that, by definition, this guy is f itself. But when we are trying to find antiderivative, we always get that plus c, and this means that I can write it either way, but what matters here is that I cannot find the function f exactly. What I can find is function f up to a constant. In other words, if I want to write this one, this will say f of x is equal to integral of f prime of x up to a constant. I cannot completely find what is the function by knowing its derivative. That is a key point for us, for those who think that, okay, now that I know how to antiderive, I can start from the derivative and go back to the function itself. In other words, that C says that antiderivative f prime does not determine f completely. There is always this constant c that we have to solve. We have to figure out what it is. And to be able to find the exact value of c, we need one more piece of information, one extra piece to be able to find that c. And that extra piece is an initial value, which is fancy way of saying that we just need to know at one point what is the value of the function at some point. Doesn't matter what point it is. So once we know the derivative and we know this initial value, then we can fix c and then go from there. Let me write an example and show you how this works in an example. So here, f prime is given. What is f itself? Okay, I can find f itself, or at least I can find the form of f, function f, which is going to be given. We know that antiderivative of f prime is f, so I can just integrate f prime, and that will give me x to the power 4 over 4, x squared plus x and c. Now, to fix that c, I need one value. So if this example, other than telling me what is f prime, if it tells me f at 0 is 1, then I can go ahead and use that information. How? I know that f of x will have this form. Now, if I plug x equal to 0, I should get 1. It means that 0 to the power 4 over 4 minus 0 squared plus 0 plus c must be equal to 1. These are all 0, so that gives me that c must be equal to 1. Only knowing this extra piece of information would tell me what is my actual function. This sometimes is called initial value condition for our equation here, or for our function. This you can repeat in more examples, and then maybe higher derivatives will come in. And I'm planning to do some examples right after this. But is there any questions, any comments before we start? If you are given f prime, to find f, you integrate, but you cannot find it until you have an initial value. And then you get what is function itself. Let's do this one, find f, if we know that f prime is x plus 1 over x, given that f at 1 is 3. Bless you. Let's do that one. Maybe I should not rush through. Okay, 14 people are in trouble. Good. So 1 minute, please. Go ahead, you know what to do. First, find the general form of f, and then use the initial value to evaluate what the value of c is. F of x is going to be given by integral of f prime. Here, this is using the rules we have. That's the general form. That's the form that our function could be. But to fix that c, we have to now use this information. Knowing that f at 1 is 3 means that if I plug in 1 into this formula, I need to get 3. So 1 squared over 2 plus ln of absolute value of 1 plus c must be equal to 3. And that means ln of 1 is 0, so that means that c is 3 minus half, which is 5 over 2. And that means that I found what is f of x with no missing information there. Any questions, any comments here? How about this one? Find f if f double prime x is given by 3e to the power x minus sine x And here, I'm given that f at 0 is 1, and f prime at 0 is 0. Before we start, before I give you some time, I'll give you 20 seconds. I'm not looking for you come up with the answer. I want you to talk to your friend sitting next to you and make sure that you see why in this question we are given two values. F at 0 must be 1. Also, f prime at 0 must be 0. 20 seconds, you're talking to your friend about why in this question we have two conditions rather than just one. Go ahead. I want to hear some chatting.
All right. Zero right now.
Since f is 0.
Okay. Can anyone tell us why? Why this time we have two conditions there? Yes, please.
We need to find the z value for the first derivative.
Here, since the second derivative is given, so we have to integrate to y's to be able to get to f. Each integration will generate one arbitrary constant c, and we need at least two conditions, two values, to be able to find that. What was the question? You were trying to tell me something. No? You're good? Okay, now I'll give you 1 minute. 1 minute after that discussion should be straightforward. You're trying to find first f prime, then f, and use the condition to fix the constants. F prime of x is antiderivative of f double prime of x, and that means that I have to integrate this guy, which will give me 3 to the power x plus cosine x plus a constant c. Yes? Now I have the form of f prime. I can find what is the form of f by integrating now f prime. When you integrate f prime, you're integrating this guy. And, well, the same story will go as we had. Derivative integral of cosine x is sine x. Integral of constant c is c times x. If your function, you're looking for a function whose derivative is constant, the function must be c times x. Now, something that you have to be very careful. Here, now I have to introduce the second constant because I integrated another time. This c was for the first integral. I have to either use c1, c2 to differentiate. There's no reason that these two constants are going to be the same. Or I can say that, oh, the constant here this time, I'm going to denote it by d. Do you see anything there? Any problem there?
So I just did a different way than what I
Okay. Yes, I want that. That's right. I wanted to do this way so that I can integrate one time that constant c. But you're right. There's more than one way to do this one. Now, my function has this property that its form is given. It's 3e to the power x plus sine x plus cx plus d. If I know that f at 0 is 1, then I can go ahead and say, OK, this means 3e to the power 0 plus sine of 0 plus c times 0 plus d must be equal to 1. This is 0, this is 0, this is 3. And that means that d is 1 minus 3, which is negative 2. Now that I have negative 2, I can find what is c. F prime of x is 3e to the power x plus cosine x plus c. We know that f prime at 0 is 0, so that gives me and that means this is 3, this is 1, so then c is negative 4. And there we go. We have the whole function. We could have, yes, we could have used this condition when we had f prime to find c, and then go ahead and use another integration and find d. That's another way of doing it, which is actually a wiser way to do it. Here I wanted to one time to integrate c for you. Any questions? Any comments? Yes, please.
Is it f of c equals 1 or f of 0 equals 1?
F at 0 was 1.
That's 0, yeah?
F prime at 0 is 0.
On the left is also 0?
This is f prime.
It's also f of 0.
F 0 is 1, yes.
That looks like a c.
Oh, is it c? Is it 0 now? Yeah? OK. Thank you. I cannot let you go before doing one more question. Let's do another iClicker question. How about that?
220.
OK. The iClicker question is open. Look how fast I get responses. This time, you're trying to find f evaluated at point if f double prime is given. And two conditions are also available for f. Am I putting everything right there? Another 30 seconds. Please get your answers in. We are almost done with the timing.
You know what? I can that.
So f prime of x is antiderivative of f double prime. So I have to integrate this guy. But then, okay, I know that antiderivative of cosine is sine. Antiderivative of x squared is x cubed over 3. What about antiderivative of e? E times x. Like 2, antiderivative of 2 is 2x. Antiderivative of 10 is 10x. Antiderivative of e is e times x and then plus constant. Now, I will do this in a bit different order. I can plug in f prime at 0 is 1. So this will be 2 sine 0 minus 0 over 3 plus e times 0 plus c. This must be equal to 1. This is 0, this is 0, this is 0. So that means that c must be 1. Now I have f prime. I can find what is f. That's antiderivative of f prime. And we get, this is integral of 2 sine x minus x cubed over 3 plus e times x plus 1 dx. Integrate that. You get negative 2 cosine of x minus x to the power 4 over 4. There is 3 here. That's 12. Plus e is constant. X, integral of x is x squared over 2. Integral of 1 is x. And then we have another constant there. Now I want to use the fact that f at 0 must be equal to 2 minus 2 cosine of 0 minus 0 over 12 plus e times 0 over 2 plus 0 plus d must be equal to 2. This is 0, this is 0, this is 0. Cosine 0 is 1, so this is negative 2. That means that d is 4. Yeah? Now I have the whole function. This is the whole function. D is 4. I want to plug in the value here. That's negative 2 cosine of pi minus pi to the power 4 over 12 plus e pi squared over 2 plus pi plus 4. Cosine of pi is negative 1. Negative 1 times negative 1 is 2. You can add that to make that one 6. And I think the answer is, again, the last one. And I'm closing the iClicker now. We're already over time. Have a great day. See you all tomorrow. Get your answers in before I close it. Just give me a second, sorry.